Here we have another example in vertex form. Underneath it, I'm just going to write down the equation for vertex form. So that was A out front. Then we call this x minus h squared plus k. Now this minus sign is to remind us opposite. All right, so remind us opposite. So remember that. And we'll talk more about the crazy house and all that stuff, my other tricks in the future, but one thing at a time. So we're going to find the vertex. We're going to find the y-intercept. I asked you for the mirror point. And, you know, mirror point, again, that's just my name for it. Don't worry about the name of it. It's more like just figuring out symmetrical from the y-intercept and the vertex. What would be that other point that's symmetrical, you know? So that's why I call it mirror point. Axis of symmetry, I abbreviate AOS, and that's always x equals a number. This other information, they're points. Points are ordered pairs, so you have to have parentheses and a comma. End behavior, which again, the end behavior we first did back when we graphed just polynomials in general. So what this is, and I've used this word a couple times, it's a subset of polynomials. So it's like, oh, polynomials is the big group within polynomials, quadratics or type of polynomial. Okay, now we're here, end behavior, and then we're gonna do the graph. So if you haven't participated yet, feel free to jump in at any time. What is my vertex? If you just want to participate in the chat, jump ahead. If you're like, she's talking about vertex, I'll put my mirror point or I'll put my end behavior in the chat. Go nuts, okay? It's fine. I'll keep an eye on it. So what is the vertex? Anybody want to tell me what that is? And remember, I want to hear from you guys throughout class. Beginning of class, middle of class, end of class, you know. Let me hear your lovely ideas and voices, you know. Go ahead, Kennedy.
I got -4 and 18.
Okay, good. What about the y-intercept? Remember, guys, you guys could jump in the chat. Then I don't even have to. Oh, see, Paige jumped ahead and did one in the chat. So feel free, guys. What is my y-intercept, Liana?
I said 0, -14.
0, -14. Okay. Did I call on you last time for the mirror point, Ella? I was trying to call on you for something different this time, and now I'm thinking like, I think she did the mirror point last time too, but whatever. Maybe you're mirror point girl.
I think I might have. I don't remember.
-2, I think, right?
I think so, yeah.
Whatever. Do this one. What would this mirror point be?
-8, -14.
Good. -8, x is double the x of the vertex. And then -14, the y is the same as the y-intercept. Where do I draw my axis of symmetry? Again, you could have put it in the chat. Like, anybody could have jumped in. Manuel, Melvin, Sol, Asaya, Sean, Tahani, Dylan, who else? Amelia, you beautiful people. So you could jump in there, even if you're wrong. At least I know you're at your computer, you know. Axis of symmetry. So what would that be? Go ahead. You want to tell me, Isa? Axis of symmetry. It's at x equals. -4? Sorry, your hand was raised. Maybe it was just up from before and you weren't ready. Yeah. Amelia, were you going to say x equals -4 for this?
Yeah.
Yeah. Okay. And then Paige says the end behavior is down, down. Okay. Jabari, question, or you were going to give an answer?
What?
I didn't know if you were about to ask a question or if you had wanted to give an answer.
The NBA kind of mentioned it too. I had down in my paper, and that's how I graphed it, but it was kind of tricky to like figure it out. I don't know. It confused me at times.
So this part was a little confusing.
Yeah.
Okay, so quick recap. Let's talk about end behavior for a minute. So if you have a positive leading coefficient, x to an even power, this is a review, the end behavior was up, up. If you have a negative, this is all if it's expanded. So if I expand this, the -2 will be out front, and this will FOIL x plus 4, and I'll have x squared as my biggest power, my biggest leading term, times -2. So my leading expression would be -2x squared, okay? So that would be positive, or no, that would be a negative number, x to an even power, and that in behavior, everything negative on the right, it finishes down. So if you have a negative outlook on life, you're just going down in life, you know, we got to turn that frown upside down. And then even means, think even like balance, same thing on both sides. So if it finishes down, that means it started pointing down. Then I'm just going to draw little squiggles between them like this. Then the odd, think ODD. If we think the word odd and flip those D's over, it looks like OPP a little, or rotate them or something. So if we have a positive x to an odd power, don't mix up positive, negative with even odd. People do that. And then if I have negative x to an odd power, positive, finish up, negative, finish down, odd, opposite. So if this is down on the right, that means it was up on the left. And if it's up on the right, it's down on the left.
That's like the cubic one.
Yes.
Yeah.
Good.
No, I don't understand what I'm doing, but sometimes I get like caught.
Yeah, it just takes practice.
Yeah.
Good questions, though. So we're here. Next. Now we would draw it, and maybe drawing it, you rode the struggle bus a little bit. Let's do my trick a little. If it's down, down, I'm going to draw a little sketcheroo. Down, down. That means that your vertex will be at what we call, I'm going to draw a little extra detail here, at a maximum. That would be a maximum point. Okay? So the vertex of a parabola, when it's got the end behavior down and down, the vertex is what we call a maximum point. It's like the mountain peak. Okay? So when I draw this, I'm going to go ahead on my paper. I'm going to put a dot on my paper, and that's my vertex. I'm going to label my vertex. I'm going to put a little V, colon. I'm going to write -4, comma, 18. There we go. Now, negative. If it was just negative, we would do the negative hashara. What's the negative hashara? Out 1, down 1, dots. Out 1, down 3, dots. Out 1, down 5. We're going the odds. Put some dots down. Out 1, down 7, dots. Out 1, down 9. Out 1, down 11. However crazy you want to go. And we make a nice graph. However, it's not just negative, it's a -2. A -2. So I'm going to teach you this extra trick. So the negative, I'm just going to scooch this to the side. When A is negative, we're taking notes, okay? When A is negative, we call that a, what's the word for this direction, up and down, versus the word for this direction? You know, we say, oh, that it went blank or it went blank. It's an H word or a V word. Which one's this, up and down?
Vertical.
Good, vertical. So when A is negative, the fancy phrase for that is we call it a vertical reflection. And that's what makes it look like a mountain instead of a valley, you know? And then when A is not 1, right? So it's a 2 or a 1/2 or a -3, right? If A is not 1, that's called it's still vertical. So A affects things vertical. Also A, help it remember how to spell vertical. It's not cle, C-L-E, vertical, like California. It's a little tall up and skinny like this. Vertical, and it would be a stretch or compression / compression. So if it's bigger than 1, we say it's a stretch. And if it's between 0 and 1, we say it's a compression. Now I'm going to show you what happens. Take your time processing this, okay? The hashara times 2, vertically only. So the out 1, out 1, out 1, you don't change that. Instead of going out 1, down 1, we're going to go out 1, double it. Down how much? Shout it out. Out 1, down.
2.
Good. Now, from those dots, you pick up where you left off for this Hashara trick. Instead of going out 1, down 3, that would be the next one. Double the down, or double the up if it were up. Out 1, down, double it. What would we get? Good. 1, 2, 3, 4, 5, 6. And then it's also really helpful too if you draw your axis of symmetry first, because then you kind of like could see the middle better. Okay, so I'm gonna go right there. Okay, out 1, normally the third one would be down 5. Double it. How far down should I go from out 1?
10.
Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right at the bottom of my graph paper here. Okay, I don't really have much more room. So there I am. Okay, then you want to use your ruler? Use your ruler. Make sure you put arrows at the end. Got that? Oh, see, you gotta, the way I was describing before is better. Hold your pen down, tilt the ruler, and go from there, you know? So it'll make it a little better. So this parabola, the Hashara had a 2 in front with that pattern. So instead of 1, 3, 5, 7, 9, we double all the numbers. If there was a 3 out front, what do you think you would do?
Triplet.
Exactly. If there was a 1/2 out front, what do you think you would do? Don't be scared. If there was a 1/2 in front, you would cut all the numbers in half. That's all. Now we're going to do my axis hack and we're done. We went left 4. So if I want to draw my y-axis, I'm going to go to the right 4. 1, 2, 3, 4. Went to the right 4. Okay, I'm going to draw. I got my ruler. Got anything straight? Oh, ignore that. That's your y-axis right there. Okay, I can't even see my y-intercept. That's fine. 18 up. So that means to go for my x-axis, I'm going to go 18 down. That was 2 and 6. That was 8. And then it was 10. That's actually 18. So my x-axis is actually at the bottom of my graph paper. I barely had room for it. So right here. Okay. Pretend. I can't even draw it, but if I stick it in here maybe. Oh, whatever. So if I drew it here, I would draw my y-axis with my ruler. I can't really do it because I kind of squeezed it on this little paper. It would go right there. That's actually my x-axis. So if I kept going down, I would see my origin. And then if I went out 1 down again, I would hit my y-intercept. Okay? So that should help you fix your graphs. That means in standard form, you would do the same idea. Once you know where your vertex is, all you do is apply the pattern. Okay? All you do is apply the pattern. So for homework, I'm going to give you just a video to take notes on factored form. You're going to take notes on that and submit your notes, and you're going to make corrections on this. And I might give you like a little bit more parabola practice of some sort if I have a chance to put it together. Okay? So I hope this helps make you a genius at graphing. If it helps, thumbs up for the video. If you're like, you're crazy, thumbs down. SOS, I need help, put a thumbs down. Okay? But this is, we're going to keep practicing. This is all really helpful tricks, and graphing is relevant in Algebra 2, pre-calculus, calculus, everywhere. So I hope you get something good out of this, okay?